Our solution to those challenges is Petrosim polymer process simulation based on Pradici polymerization model. Sorry. KBC partnered with CIT, which stands for Computing and Technology, which was founded by Dr. Michael Wilko in Germany. I believe he's going to be joining us at the Q&A at the end. So if you do have specific questions for about Pradici, um, he will be there to answer them. So KBC partners with CIT to provide polymerization reactor design, operation, and performance analysis inside process simulation. Pradici, one of CIT's product, is a robust and user-friendly software for modeling polymerization reactions. It has been successfully utilized in hundreds of projects in industry and academia for over 25 years. It's the leading simulation software for kinetic, property, and polymer reaction modeling. With this partnership, we developed a unit operation called Pradici Sim, which allowed us to integrate polymerization into Petrochem's rigorous flow sheeting capabilities. Um, this will allow you to reduce scale up risk and experiment time. It'll allow you to better predict yield, molecular weight distribution, melt flow index, emissions in both steady state and dynamic models. It will allow you to analyze KPI, carbon intensity tracking, and help with troubleshooting. It will also allow you to optimize plant efficiency, grade transition, and carbon intensity. In the case of where you want to change production to produce different polymer grade, this will allow for new grade property prediction and shorten experiment time. And over time, you may want to, or a client may want to change their plant. This will help with conduct revamping and expansion studies. It's right here, but there it is. So for calibration, in this case, we have a tab called calibration setup, and the data set is the page that you would enter in your measured data. So when you're running an experiment, you have at various point in time, there are certain properties that you are able to measure. So in this case, you can have I only have one time entry, but you can have multiple time entries in there. So in here at the say at the 100-second point, found a conversion at 19.7, and the molecular weight, we have those as measured values. Other ones we don't know anything about. So this is our data set. And then when you come here, these are the reaction tuning factors. And down here you can have multiple data sets. In this case, I'm just going to try to fit the model, the kinetics to our first data sets, measured data. So you can play with different, trying to see the effect of how the kinetics affects those particular properties. So in this case, as a starting point, I have my factors being 0. I'm changing the coefficient kinetics that affects the propagation and one that affects the transfer. Here's 0. So I'm just going to send this to so this part's the same behavior as everything else. You just send it to calibration, and then I'm just open this up so we can see what's happening. And then you run your calibration. And then you can see here, um, it's using the parameter estimation tool, and it's trying to fit the data. Oh, fit the data. So here, came back, it's saying it's successful. And you can see in here, our initial value was 0. In order to, so it's just basically saying in order to have this particular model fit those two measured values, um, the kinetics for these two have to needs to be changed to these values, and then you can accept and reject just like any other calibration runs. Um, so this concludes my demo.